All right, guys, practice for benchmark number 3. We're going to do that tomorrow in class. This is substitution. Anytime this equation down here is helpful, anytime I see a y, I can plug in 3x minus 8. They're the same thing. So I'm going to rewrite this equation with 3x minus 8. And I'm going to rewrite the whole thing over here, but instead of y, I'm going to rewrite it with 3x, x plus 3x minus 8, right? I'm going to take out the y. I'm going to plug in the 3x minus 8, and that equals 16. All right, we don't have to figure out both. We only have to figure out the x for this. So make your teams, make your teams, make your teams, make your teams, send these have to combine, this has to go over there, and then solve what the equation will be. Or solve what the x is. Number 2. All right. All right. When we have equations like this, we're allowed to do things to them. We can shift them around, we can make them bigger, we can make them smaller. We want another equation that has infinitely many solutions. The only equations that have infinitely many solutions are the ones that are exactly themselves. So check this out. I can have 2x plus 4y equals 12. And maybe I want to multiply everything by 2, everything in the whole equation by 2. And that would make this 4x plus 8y equals 24. That would be exactly the same equation. And that would have infinity solutions. Maybe I wanted to multiply by -1. And now I turn it into -4x minus 8y equals -24. That would also have -24. That would also have infinity solutions, because really all these equations are the same equation. You've just you made it look different, but they're the same thing. So can I make this one smaller? Yeah, I could divide this one by, I don't know. Well, I could divide by 4. I could divide this one by 4 and say -1 minus 2y equals -6. So as long as you do it to the whole equation, you can change the equation. Can you get this guy? Can you get where we started? Let's see. Let me erase. What if we started with this one? Can you get this guy to look like any of these? Only one of them can you change into something. Let's see. What would you need to do to make him look like something? All right. Think about it. Good luck. All right. Infinitely many solutions. There's 2 ways to do this. Either, this is the x and this is the y. Either I plug in 1 for the x and 5 for the y and 1 for the x and 5 for the y and see if it works. Or this one is the x and the y. So maybe I plug in 5 for the x and 1 for the y and 5 for the x and 1 for the y and see if it works. If neither of them work, maybe I do the good old eeny, meeny, miny, mo, catch a tiger by the toe. But the right way to do it is this is elimination, right? We have a column of x's, we have a column of y's, we have a column of numbers. We need one of them to cancel each other out. And I see -3 versus +1. So if I just made this top guy 3 times bigger, everybody in him 3 times bigger, I think they would cancel out. So I could rewrite that top equation and make everything 3 times as big. So instead of 4 x's, I'm going to make it everything 3 times as big. 12 x's plus 3 y's equals 63. And I've got 2 x's minus 3 y's equals 7. The bottom guy I left the same. And now check it out. 12 x's and 2 x's is 14 x's. 3 y's and -3 y's, they cancel each other out. 63 and 7 is 70. And now you should be able to figure out what x equals, and you should know that it's one of those answers because only one of those has that as the answer. All right, so go ahead and try that one. Number 4. Here's Andrew's graph, here's David's graph. When are they going to be the same? How can you tell when they're going to run into each other? Well, I know their slopes. I know this one goes, right? If I know their slope, boom and boom, I can continue this line because I look for the corners. If I know this one, boom and boom, I can continue their lines using their slopes. And maybe they run into each other somewhere. All right, number 5. This is the hardest question here. It's the most involved. And here we go. Okay. This one says, check out the first one right here. 2 lines that have the same y-intercept. Okay, let's think of 2 equations that have the same y-intercept, right? Like, that's where it starts. So over here, they have the same y-intercept. This equation has 5 as its y-intercept. It's begin on blue number, and this number has 5. Okay. And also the same slope. Okay. This guy has a slope of 2. This guy has a slope of 2. Okay, we have 2 equations that have the same y-intercept, 5, and the same slope. Let's see, how many times do they intersect? This says there's going to be 1 intersection. Intersections are answers. How many solutions does it have? This says if you have the same slope or the same y-intercept and the same slope, you're only going to have 1 answer. That's what it said. They're going to intersect at 1 point. That means there's 1 answer. But that's not right. We know that if you have 2 x's and 2 x's, those guys are going to get rid of each other. And plus 5 equals plus 5. No, there's not 1 answer. There's infinity solutions. So no, they're not going to have 1 answer. They're going to have infinity solutions. So that's not true. Not true. Never is it going to be 1. It's always going to be infinity. All right, let's think of the next answer. What if 2 lines have the same y-intercept? Okay, they have the same plus 5. Okay. But they don't say anything about their slope. So maybe they have the same slope, like up here, like this one that we just did. They have the same slope, 2x. Well, I know the 2x's get rid of each other. And plus 5 equals plus 5, so that's infinity solutions. All right, but if you have the same y-intercept, right, you have plus 5 and plus 5. They don't say you have the same, maybe you have the same slope, like the top one, but maybe you don't have the same slope because they didn't say we have to. So this one down here, same y-intercept, plus 5 and plus 5, but now a different slope, 2 x's and 3 x's. Well, if you have different x's, they're not going to cancel out. This is just a normal old problem. So if you have the same y-intercept, sometimes you're going to have infinity solutions if you have the same amount of x's. Sometimes you're only going to have 1 answer if you have a different amount of x's. So do these lines intersect at 1 point? Is there always going to be only 1 answer? That's what they're saying. Sometimes it'll be 1 answer. Sometimes it'll be infinity answers. All right, let's see. 2 lines that have the same slope. So we're going to have the same 2 x's as their slope. 2x is their slope. Says do not intersect ever. Okay, but what if they have, so we have 2 equations. This one has the same slope. This one has the same slope. And then they don't say the back numbers are same or different. So what if they're the same? What if they're different? Okay, well over here the 2 x's are going to cancel each other out, 5 equals 5, that's infinity. 2 x's cancel each other out, 2 x's cancel each other out, 5 equals 6, that's no solution. So are they going to have 1 answer? They intersect at 1 point? No, never. It's either infinity or nothing. Okay, so it's never true. Not true. Oops, that was the wrong one. Out. Sorry. Okay, let's see. 2 lines that have the same slope do not intersect at any points. Yeah, sometimes they don't intersect. And then sometimes they intersect all the time. So true sometimes. All right, and finally, the last one. What if they have different slopes? Let's see, different slopes. Okay, let's follow this line over here to do these 2. What if you have different slopes, like 2 x's and 3 x's, and over here you have 2 x's and 3 x's, then we might have the same back number, like 5 and 5, we might have a different back number, 5 and 6, because all they said is what happens if your first number is the same or different. So let's see, 2 x's and 3 x's, well, if they're different, you're going to have, it's just a normal old math problem, you're going to have 1 answer. Doesn't matter what your back answer number is. So they could be different. 5 and 5 doesn't matter. 5 and 6 doesn't matter. If the x's are different, you're going to have 1 answer. So if the x's are different, You're always going to have one answer. They intersect at one point. Intersections are answers. Yes, true, always. No matter what, you're going to have one answer. Okay, hopefully that makes sense. If not, good luck.